Hello to everybody and welcome to the second theoretical lecture of this course of Mathematical Analysis 1. The first topics of today is the maps. I already announced in the previous lecture that I will have talked about maps. Another word for maps is applications. And you will use this word especially in the course of geometry. And the third word, which is very famous and we will use very extensively along the course, is functions. Okay? So what is a function? And I give you the abstract definition. This definition is extremely important. I want you to learn it by heart, but not only by heart, you have to understand it at a deep level. So what is a map? A map is the following thing. You have two sets, A and B, and the definition says given these two sets A and B, think of them as being non-empty. It is better, but okay. So a map or application or function between the sets A and B is a rule of correspondence between the elements of A and the elements of B. But it is not the end. The most important part of the definition is now. Because this correspondence must be such that to every element of A of the set A corresponds one and only one element of B. Okay, this is a definition. This definition now can seem not so clear, so I give you some example. But before the example, let me give you a pictorial representation of this definition. We will use the Euler-Venn diagrams and start with this two set A and B. Elements of A are represented by dots inside A and elements of B by dots inside B. And now we have to establish a correspondence between the elements of A and the elements of B. So for instance, you can take this element of A and send it towards this element of B. An arrow will clarify from which set to which set the correspondence go. And now take another element and put it here. one could be tempted to add another correspondence for the same element, for instance, to do like that. But this is forbidden by the definition, because the definition says that to every element of A, and this is good, corresponds one and only one. One and only one is a strange way of speaking, but the idea is that there always corresponds one and only one. So in this case, we tried to let two elements of B, this guy here and this guy here, corresponds to the same element of A, and this is forbidden. So this is forbidden by the definition of map, of function. You can do that, but then the correspondence you define is not a function. If you want to stay into the definition of function, you have to cancel one of the two correspondences. Vice versa, think of sending this point of A here toward this point of B that has already been reached by another arrow. This is not forbidden. This is allowed. This is allowed, and you see it here, because we say that to every element of A corresponds one and only one element of B. But we never say that to different elements of A there must correspond different elements of B. In principle, all elements of A could go, why not, to the same element of B. This is not forbidden. Okay? And moreover, what I represented here up to now is not a function, because we have to find an arrow for every element of A. So for instance, this guy here, here, this guy here, here, and then here, and then here. Okay, this is a function. To every element of A, there is an element of B. Notice that here, there is an element of B that is not reached by any element of A. It's no problem. It can be. It does not contradict our definition. Okay? So let us see some example, not a mathematical example, at least. We can start by examples that are not really mathematical. So before giving an example, let us complete the definition with the notation. And notation to denote a map F, typical name for the map because it stays for function, a map F from the set A to the set B, one usually writes F, then double dots from A to B. As a first line, as a second line, one can write something like this. X, which is considered to be as a generic element of A, is mapped to f of x. So it means that the generic element x of A is mapped by f to the element f of x of B. Okay, this is the interpretation of this way of writing. And so just to tell you some names, so the set A is called the domain. Of the map F the set B is called the target set, or simply the target of the map F, and then f of x, which is an element of B, is called the image of x, element of A, through the map F. This is just a way of speaking, but it must be, this language must become natural to you, okay? So it is very important that you absorb it to a deep level, okay? And then another very important definition is the following: the range. This is important. Also, the previous one was important. Definition of function in a course of mathematical analysis 1 is extremely important. I don't need to write it. Here, perhaps I need to write it. So I write definition. And this is important, extremely important. Is the definition of range. The set, let me write it and then we will explain. Range of F. Another symbol is F of A. Another symbol is range where X run in A. These are just symbols. And the definition is the following: is the set of all the y's in B such that there exists an element X in A whose image is Y. This set is called the range of the function f. Okay? So as I told you, this definition is very, very, very important. But what does it mean? Because perhaps most of you did not understand it through these symbols. It means the following. Consider the previous picture. So I will just move or copy this picture from here to here. Oop. I capture something. Okay. Notice here this function. This is our f. And notice that, as I already highlighted, not all points of B are reached by an arrow. There is one point. There is one point which is outside the reach of the map. Okay? So, what is the range? The range is the set of all the elements of B, so all the dots E, such that there exists an X in A that is mapped into Y. So this guy here has no element of A mapped into itself. So it does not belong to the set range of functions. Whilst all the other points are reached by the map, so they belong to the set range. So morally, so as a comment, the range of a function is the set of the elements, made of the elements of the target that are actually reached by the function. In which sense? In the sense that they are actually the image of an element of the domain A. Okay, do you agree? So, and let me try to do some example, not mathematical examples, but first example is the following. A is the set, for instance, of women. Women along the history, in the whole human history. And B is the mankind. And now the function f from A to B associates to every woman X Y, an element Y of the mankind, such that Y is a son or a daughter of X. So the question is the following: is f a true function? Turn it off, think of it. Now, come back, and the answer is no. Why? One reason is, for instance, that there are women with more than one son or daughter. And the definition of function states that to every element of the domain there must be associated only one element of the target set. So this is not a function, because the function associates to every x too many elements. So try to do the second example and to change it a bit. And the example is very similar, so let me copy it. Again, the set A is made of women along the human history. B is mankind. F from A to B associates to every X, to every woman X, Y, such that Y is, and here let me correct a bit, is the first son or daughter of X. Now think of the fact whether this is a good function or not. And again, the answer is no. Why? Because there are women with no offspring. With no sons nor daughters. And why is this a problem for our definition of map? It is a problem because our definition says to every element of A corresponds one and only one element of B. To every element of A. So, in this case, every element of A can only refer to women who have sons or daughters. Otherwise, it has no meaning. So let us modify again this example and try to see whether we have. Sorry for this discussion, I have to cancel this notification I will do for the next lecture, of course. So, the third example, again, women in the whole human history, and with offspring. And B is mankind. So F from A to B lets to every X corresponds Y, such that Y is the first son or daughter of X, the first descendant. Okay, now one can say that there is a problem with twins, but I think there is always one twin that comes out before the other, so we can define which is the first descendant. So let me be naive enough in order to say that this is a function or map. Because to every element of A, there corresponds one and only one element of B. Okay? And this is all. And let me introduce other two definitions that are extremely important. And the first definition is the following. A map or function f from A to B is called injective. This is a very important word, we will use it a lot. It's called injective. If whenever you have that f of x1 is equal to f of x2, in the sense that there are 2 points, 2 elements of A sharing the same image, then the 2 elements are the same. So, morally, we can say that different elements of A have different images. Okay, this is the main fact. And so, for instance, in the previous example of a function, in example 3, the function f, the unique function we managed to define, is injective. Another example now, let me do a mathematical example. We have f from a set, let me call it R to R. We still did not define it, okay? But just to use the language, we will define R in some other parts of our lecture that associates to every x squared. So this is the parabola, the map that squares. So we have to say whether it is injective or not. You already know the answer. We will see how to draw the graph of a real function of a real value. This is the heart of the course, but now let me just draw a parabola. So is it injective or not? In order to be injective, it must be that every element in the range is made of non-negative number, so range f is equal to the set of all x larger than or equal to 0. So we have to find only one point that is mapped there. But here we have 2. Here we have this x1 here, and here we have another point that will be minus x1. So there are 2 points are mapped by f to the same element of the target set. Then f is not injective. Okay, stop here this first part.